For centuries, humans have gazed up at the night sky and wondered, are we alone in the universe? This question has haunted scientists, philosophers, and dreamers for as long as we've understood our place in the cosmos. Given the vastness of space and the sheer number of stars and planets in our galaxy alone, the odds of Earth being the only planet to host intelligent life seem extraordinarily low. And yet, despite decades of searching, we have found no solid evidence of extraterrestrial life. This is the Fermi Paradox, a question that challenges our understanding of life in the universe. The paradox lies in the apparent contradiction between the high probability of extraterrestrial life and the complete lack of evidence for or contact with such civilizations. The question begins with the assumption that, statistically speaking, with so many stars and planets, intelligent life should be common in the universe. Given that the Milky Way alone has over 100 billion stars, many of which have planets in the habitable zone, life should, by all logic, be widespread. Yet, despite this, we have not found any definitive signs of extraterrestrial life. This leads to the core question: where is everybody? If there are so many planets capable of supporting intelligent life, why haven't we detected any alien signals, visited their worlds, or even encountered any signs of their technology? The absence of evidence, in this case, seems to contradict the overwhelming odds that life must be out there. The Fermi Paradox first emerged during a casual conversation among scientists in the 1950s. In 1950, physicist Enrico Fermi, one of the most influential scientists of the 20th century, famously remarked, "Where is everybody?" This simple but profound question arose during a discussion about the possibility of life elsewhere in the universe. Given the number of stars and planets, it seemed inevitable that intelligent life should be common. Yet, the question of why we have found no evidence of such life has persisted ever since. The paradox is rooted in one key assumption. The vastness of space implies intelligent life is likely widespread across the universe. With billions of stars and planets, many of which are in the habitable zone where life could exist, the likelihood of intelligent life evolving elsewhere seems high. But despite high odds, we have yet to detect any signs of alien life. This brings us to the Drake equation, formulated by astrophysicist Frank Drake in 1961. Which tries to estimate the number of active communicative extraterrestrial civilizations in our galaxy. The equation multiplies factors like the rate of star formation, the fraction of stars that have planets, the number of planets that could potentially support life, and the fraction of those that might develop intelligent life. The equation suggests that even if only a small fraction of stars harbor life, the Milky Way could host billions of civilizations. So if the odds are so favorable, why haven't we found any evidence of these civilizations? Why, after decades of searching, do we still have no definitive evidence of alien life? This is the puzzle at the heart of the Fermi Paradox. With the age of the universe and the vast number of planets, if intelligent civilizations are common, why haven't they already made contact with us? The universe is 13.8 billion years old, and the Milky Way galaxy is about 13 billion years old. If intelligent life emerged just a few million years before us, it would have had plenty of time to spread across the galaxy, perhaps even colonizing other planets. So why haven't we encountered them? Despite efforts like the Search for Extraterrestrial Intelligence, SETI, which has been scanning the skies for alien signals since the 1960s, and missions to explore our own solar system, we have yet to find any definitive evidence of alien life. The lack of evidence is even more puzzling when we consider the size of the galaxy. The Milky Way alone is home to over 100 billion stars. Given that each of these stars may host planets in the habitable zone, it seems unlikely that Earth is the only planet with intelligent life. The paradox leads to several potential explanations. Some suggest that intelligent life is incredibly rare and that the formation of technologically advanced civilizations is an exceedingly rare event in the cosmic timeline. Others propose that technological civilizations are short-lived and they self-destruct before they can establish contact with other civilizations. The idea that civilizations destroy themselves before they can reach a level of technological advancement capable of interstellar communication or travel is a sobering thought, especially given humanity's increasing capacity for destruction. This brings into focus our responsibility to manage our technological advancements to ensure our survival. Another possible explanation for the Fermi Paradox is that alien civilizations are deliberately avoiding us. Some theories suggest that advanced civilizations may be aware of us, but choose not to make contact, either because they consider us too primitive or because they follow a principle similar to the zoo hypothesis, which posits that advanced alien civilizations observe less developed ones without interfering. Perhaps they have chosen to allow us to develop on our own, much like how we observe animals in a zoo. Yet another possibility is that alien civilizations may be out there, but they could be so far away that their signals have yet to reach us. The vast distances between stars and the speed at which light travels mean that even if alien civilizations exist, their signals might be too faint to detect or might not have reached us yet. Additionally, it's possible that we are looking for the wrong kinds of signals. Our methods of searching for extraterrestrial life, such as listening for radio waves, may not be the right approach. Aliens might be using different forms of communication that we have yet to discover or understand. This would mean that the absence of evidence is simply a result of our inability to detect their presence, not their absence. The Fermi Paradox challenges our assumptions about the universe and our place in it. It forces us to confront the possibility that we might be alone in the cosmos, or it might suggest that we're simply too early in our development to detect the vast network of intelligent life that could be out there. Either way, the question remains: if alien civilizations exist, why haven't we found them yet? And perhaps more importantly, what does that mean for the future of humanity in the universe?
As we continue exploring the Fermi Paradox, it's essential to understand the assumptions that underlie the paradox itself. The core idea is that the universe, with its billions of stars and planets, should be teeming with intelligent life. Given the vastness of space and the statistical likelihood of life existing on other planets, the silence we observe seems paradoxical. To comprehend why the Fermi Paradox is so perplexing, we must first look at the factors that make the existence of alien civilizations seem so inevitable. First, we consider the sheer number of stars in the universe. The Milky Way alone is home to over 100 billion stars, many of which likely have planets orbiting them. Scientists estimate that there are billions of potentially habitable planets in our galaxy alone, many of which are in the so-called habitable zone, the region around a star where liquid water could exist. Water is a key ingredient for life as we understand it, so the presence of water on a planet dramatically increases the likelihood that life could develop there. When you expand this concept beyond the Milky Way, the numbers become even staggering. There are over 100 billion galaxies in the observable universe, each containing billions of stars. If even a tiny fraction of those stars host planets that could support life, the chances of intelligent life emerging somewhere in the universe seem extraordinarily high. This creates a kind of cosmic optimism. If intelligent life is a product of basic natural processes, then it should be ubiquitous throughout the galaxy. But there's another factor that amplifies the paradox: the age of the universe. The universe is 13.8 billion years old, and the Milky Way galaxy is about 13 billion years old. This means that intelligent civilizations, if they evolved on other planets, would have had ample time, far more than us, to develop advanced technologies, potentially far surpassing our own. Civilizations capable of interstellar communication or even space travel could have existed millions of years before us, and if they had, they would have had plenty of time to make their presence known. Yet, despite this, we have no evidence of their existence. This brings us to a critical question. If civilizations like ours have had time to develop, why haven't we heard from them? Why hasn't any alien civilization made contact, left signs of their presence, or even attempted to reach out? The absence of any detectable signals from alien civilizations in the vastness of space is a central aspect of the Fermi Paradox. After all, according to the statistical odds, civilizations should be abundant, and the technologies they've developed should be detectable, whether through radio signals, megastructures, or other advanced forms of communication. This paradox leads us to another essential idea: the age of civilizations. If intelligent life is common in the universe, why hasn't it resulted in intergalactic communication or exploration? The galaxy has existed long enough for intelligent civilizations to spread across vast distances, yet we still see no signs of alien activity. One explanation is that civilizations might be short-lived, self-destructing before they can reach interstellar communication or space travel. Human history, with its wars, environmental destruction, and the potential risks posed by advanced technology, suggests that intelligent civilizations could be prone to self-destruction. Perhaps we are not alone, but the civilizations that existed before us, or even those currently out there, have already fallen victim to their own technological advancements. While the idea of self-destruction is unsettling, it is a real possibility. In fact, the concept of a short-lived civilization is one of the leading explanations for the Fermi Paradox. If civilizations tend to destroy themselves before they reach a point where they can communicate or travel across the galaxy, then it would explain why we don't hear from them. The fact that we have not made contact with other civilizations could be a testament to the fact that the lifespan of an advanced civilization is shorter than the time it takes to colonize the galaxy. This idea is supported by the Great Filter hypothesis, which suggests that there may be a major obstacle or a filter that prevents life from reaching a high level of technological advancement. The filter could exist at any point in the development of a civilization, from the initial emergence of life to the ability to communicate across interstellar distances. If the filter lies in the future, then it would mean that advanced civilizations are destined to destroy themselves before they can colonize the galaxy. If the filter lies in the past, then we may be the rare survivors of a long evolutionary process, and the Fermi Paradox would simply reflect our unique place in the timeline of life in the universe. Another theory to consider is the possibility that alien civilizations are deliberately avoiding us. If there are other civilizations out there, they might have the technological capabilities to observe us, yet choose not to interact with us. This idea is central to the zoo hypothesis, which proposes that advanced civilizations are intentionally avoiding interference with less developed civilizations, like observing us as we observe animals in a zoo. According to this theory, extraterrestrials might be aware of us, but for ethical or observational reasons choose not to contact us. Perhaps they are waiting for us to reach a certain level of technological or social maturity before making contact. It's a chilling thought to consider that we might be under observation right now, with civilizations out there watching us evolve and waiting for the right time to make their presence known. These ideas are only the tip of the iceberg when it comes to understanding the complexities of the Fermi Paradox. While the search for alien life continues, these theories help to explain why, despite the statistical likelihood of extraterrestrial civilizations, we have not yet detected any. Whether due to self-destruction, isolation, or the vast distances between us, the Fermi Paradox raises profound questions about the nature of life in the universe and the future of human exploration. As we continue to look outward toward the stars, the Fermi Paradox remains a powerful reminder of the vast unknowns that lie ahead. We must ask ourselves, are we truly alone in the universe? Or is there something else, something we're not seeing, keeping us in the dark?
As we continue to unravel the mystery of the Fermi Paradox, we must consider the implications of the Great Silence, the overwhelming absence of any signals, messages, or signs of extraterrestrial life. It's a silence that seems to stand in direct contradiction to the vast potential for intelligent civilizations. If life is common, why haven't we heard from anyone? This question brings us to a central piece of the Fermi Paradox puzzle: the difficulty in detecting alien civilizations. The first obstacle we encounter is the sheer distance between us and other potential civilizations. The distances involved in space travel, or even communication across space, are immense. The speed of light, which is the fastest known method of transmitting information, is incredibly slow when compared to the vast expanse of the universe. Even if a technologically advanced civilization existed in a distant star system, any signal they sent out would take years, if not millennia, to reach us, and our signals would have the same limitation. For example, the closest star to our solar system, Proxima Centauri, is over 4.2 light-years away. That means that if an alien civilization sent a signal from that star, it would take over 4 years to reach us. And that's just the nearest star. The vast majority of stars and potential planets that could support life are much farther away, often hundreds or thousands of light-years from Earth. With the current state of our technology, even the fastest spacecraft we've built would take tens of thousands of years to reach these distant worlds. In this context, even if extraterrestrial civilizations are out there, they may simply be too far for us to ever make contact. But distance is just one of the barriers. Detection itself presents another enormous challenge. Our efforts to detect alien life have primarily focused on listening for radio signals, a form of communication that we ourselves use to send messages across space. The most famous example of this search is the SETI program. which has been scanning the skies for radio signals for decades. While SETI has made some promising observations, it has found no conclusive evidence of alien transmissions. The reason for this is simple. We may be searching for the wrong thing. Radio signals are just one form of communication, and aliens may not use the same methods we do. Advanced civilizations might have developed technologies far beyond our current understanding. Communication methods that involve quantum mechanics, laser signals, or other forms of light-based communication that we're not yet capable of detecting. Just because we haven't heard anything doesn't mean no one is trying to communicate. Moreover, there's the possibility that extraterrestrial civilizations aren't broadcasting signals at all. Many scientists have proposed that intelligent alien civilizations could be deliberately radio silent, avoiding any detectable signals to remain undetected by potential threats. In a universe where the potential for hostile civilizations exists, it might be a survival strategy to avoid drawing attention. The idea that civilizations might hide their existence is referred to as the dark forest theory, which suggests that in the vastness of space, it's safer to stay quiet, as any civilization that reveals itself might risk being destroyed by others. The analogy often used is that of a dark forest, where any creature that makes a noise risks being hunted by something much more powerful. This idea of self-imposed silence raises another possibility. Perhaps alien civilizations are already aware of us, but they choose to observe without making contact. They might view us as too primitive or unready to interact with more advanced species. This concept ties into the zoo hypothesis, which suggests that advanced civilizations are deliberately refraining from interfering with our development, much like how we study animals in a zoo without disturbing their natural behavior. If this is the case, the absence of evidence could be the result of a conscious decision to leave us undisturbed until we're ready for contact. But if alien life exists but is simply not trying to communicate, the Fermi Paradox becomes even more perplexing. Why would these civilizations avoid us? Is it because they're too advanced for us to comprehend? Or is it because they simply don't see us as important enough to engage with? The zoo hypothesis and the idea of deliberate silence pose unsettling questions about how we might be perceived by intelligent alien species. Are we a species waiting to be discovered, or are we just an insignificant, unnoticed part of the universe? But it's also possible that we're missing the signs of extraterrestrial life altogether. Our search for life is rooted in our own understanding of biology, based on carbon-based life forms and the presence of water. However, life elsewhere in the universe might not be like us at all. It could be based on entirely different chemistry or biological processes. Imagine life that exists in extreme environments, or non-carbon-based life that thrives in conditions unimaginable to us. If alien life exists in forms that are radically different from our own, it may not even resemble anything we recognize as life. This concept is known as life as we don't know it, and it would radically alter how we detect and understand extraterrestrial life. We might be looking for the wrong signs, assuming that alien life would look like us or have similar needs and characteristics. Even within the framework of life as we understand it, detecting alien signals or signs of civilization could be extraordinarily difficult. As we mentioned earlier, the vastness of space means that any signals from distant civilizations would take years or centuries to reach us. And even if we receive those signals, they might be so weak that they are drowned out by the background noise of the universe. Additionally, extraterrestrial civilizations may be using technologies that are far beyond our current ability to detect, such as laser communications, gravitational wave signals, or forms of electromagnetic radiation that we haven't even conceived of yet. Just because we haven't heard anything doesn't mean no one is trying to communicate. And finally, there's the possibility that alien civilizations are simply not broadcasting any signals at all, because they don't need to. If we look at our own technological progress, humanity is increasingly shifting towards more subtle forms of communication. With the rise of cryptography, quantum computing, and secure digital networks, the idea of broadcasting an open signal across space might be seen as unnecessary, inefficient, or dangerous. Advanced civilizations might prefer more private or secure forms of communication that don't rely on broadcasting signals into the void of space. All of these ideas lead us back to the heart of the Fermi Paradox, the absence of evidence. Despite the billions of stars and planets in the universe, the silence persists. The question remains, why haven't we found any alien civilizations? Is it a matter of distance, or are we simply looking for the wrong things? Are the aliens out there just waiting to be found, or are we alone in the vastness of space?
Now that we've explored some of the reasons behind the absence of detectable alien life, it's time to delve into the more speculative theories that attempt to explain the Fermi paradox. Well, we've already discussed ideas like the rarity of intelligent life or the possibility that alien civilizations self-destruct. There are many other potential explanations, each attempting to solve the paradox in its own way. One theory suggests that the existence of extraterrestrial civilizations might be extremely rare. This idea is known as the rare Earth hypothesis, which posits that Earth's combination of conditions that allow for the development of intelligent life, such as the right distance from a star, a stable climate, in the presence of liquid water, may be so unique that the probability of it occurring elsewhere in the universe is incredibly low. According to this hypothesis, Earth may be one of the few, if not the only planets in the galaxy capable of supporting intelligent life. The rare Earth hypothesis doesn't rule out the existence of simpler forms of life, like bacteria or single-celled organisms on other planets. However, it suggests that the development of complex, intelligent life, like that which exists on Earth, requires such a specific set of conditions that it's statistically improbable to find it elsewhere. The unique and fortunate conditions on Earth, such as a stable orbit around a relatively small star, the presence of a large moon to stabilize our planet's tilt, and the protection of a magnetic field, may be just a few of the factors that made our planet capable of supporting intelligent life. If these conditions are rare, the likelihood of finding another Earth-like planet in the vast expanse of space diminishes significantly. Another speculative explanation for the Fermi paradox revolves around the concept that advanced civilizations are out there, but they might be so advanced that we are unable to detect them. As we've discussed, the universe is 13.8 billion years old, and humanity is just beginning to scratch the surface of our technological potential. What if alien civilizations have developed technologies far beyond our comprehension? They might be operating on principles that are completely foreign to us, beyond our ability to even detect or recognize. For example, extraterrestrial civilizations might use advanced physics or quantum technologies that allow them to communicate or interact in ways we cannot fathom. Just as early humans had no concept of electromagnetic waves before the discovery of radio, perhaps we are missing the key to understanding alien technologies. These civilizations might be invisible to us, operating on wavelengths or dimensions that we can't detect with our current scientific tools. It's possible that the aliens aren't using radio signals at all, but instead rely on methods of communication that lie outside of our understanding of physics.
This idea feeds into the notion that advanced civilizations may have reached such a level of technology that they've learned to manipulate space-time itself. Perhaps they've developed the ability to create wormholes or use other forms of interdimensional travel that make them effectively invisible to us. If their technology allows them to exist in a different dimension or hide within alternate forms of space-time, we might never be able to detect their presence, no matter how advanced our instruments become. Then there's the possibility that extraterrestrial life is already here, but we simply don't recognize it. This theory suggests that alien life forms might be present in forms we cannot identify, due to the vast difference between our biology and theirs. For example, what if intelligent alien life forms don't rely on carbon-based biology or the same chemistry we understand? What if their existence is so different from ours that we can't perceive them in any meaningful way? It's conceivable that they might operate within the same physical space as us, but their biology and behavior are so foreign to our sensory capabilities that we fail to recognize them as life. This concept is similar to how early humans might have struggled to perceive microbes or other microscopic life forms before the invention of the microscope. If alien life exists in forms that are beyond our sensory capabilities or understanding, we could be living side by side with them without even realizing it. It raises the question of what constitutes life itself, and whether our current definition of life is too limited. Just because we haven't found intelligent life that matches our understanding of biology doesn't necessarily mean it's not out there. It just might be completely different from what we expect. Another popular theory is that alien civilizations are deliberately avoiding us. This idea suggests that alien life forms might be aware of us, but for one reason or another, they've chosen not to make contact. This concept is sometimes called the prime directive, a concept that has been popularized by science fiction, especially in Star Trek. According to this idea, more advanced civilizations may follow a rule of non-interference with less developed species, allowing them to evolve naturally without outside influence. If this theory holds true, it would mean that aliens are aware of us, but are simply waiting for us to mature, to reach a level of technological or social development where we are ready for contact. The reasoning behind this idea is that advanced civilizations may see us as too primitive or too dangerous to engage with. After all, humanity's own history is full of examples of how contact between more advanced civilizations and less developed societies has often resulted in the destruction or exploitation of the less advanced group. It's possible that alien civilizations view our current state of development and our ability to destroy ourselves through nuclear war or environmental collapse as reasons to keep their distance. If they have the ability to observe us, they might be watching from afar, waiting until we are ready to interact with them responsibly. Finally, we can't ignore the possibility that alien civilizations are simply too far away for us to detect. The universe is so vast, and even the closest stars are located light years away from us. The distances involved in space travel are almost incomprehensible, and even if extraterrestrial civilizations are out there, they might be so far removed from us that we would never encounter them in our lifetimes. Even if we had the technology to reach the nearest stars, it would take tens of thousands of years to make the journey. The size of the universe may make it impossible for us to ever meet another civilization, even if they exist. The vastness of space presents one of the greatest challenges to interstellar exploration and communication. The light-year distance between stars means that even if we could send a signal, it would take decades or even centuries to reach another civilization. And that's assuming they're listening. The possibility that alien life exists, but is simply too far away to detect or communicate with, is a sobering thought. But it also underscores the scale of the challenge we face in our search for extraterrestrial life. As we continue exploring the Fermi Paradox, we now turn to a fascinating possibility: the technological and spatial challenges that may explain the lack of contact with extraterrestrial civilizations. While we've already discussed ideas like self-destruction, deliberate silence, and even the vast distances between us and other civilizations, the sheer scale of space itself presents a unique challenge. The speed of light is the fastest thing we know, yet it's still incredibly slow when compared to the vast distances in the universe. Even if extraterrestrial civilizations were sending signals our way, the distance between stars, galaxies, and potential alien worlds could prevent us from ever receiving them. Let's consider the immense size of the universe. The observable universe is estimated to be 93 billion light-years across, and it's constantly expanding. Even within our own galaxy, the Milky Way, the distance between stars is staggering. The average distance between stars in the Milky Way is about 4.24 light-years. Just to travel to the closest star system to our own, Proxima Centauri, would take a spacecraft traveling at the speed of light over 4 years. For reference, the fastest spacecraft ever launched by humanity, the Parker Solar Probe, travels at speeds of up to 430,000 miles per hour. At that speed, it would take thousands of years to reach even the nearest stars. So, how could a civilization separated by such vast distances communicate or travel to us? The very scale of the universe makes it difficult, if not impossible, for interstellar travel or communication to happen within human lifetimes. This brings us to the fundamental problem of interstellar travel. The distances involved are simply too great. Even if alien civilizations were out there, the challenge of traveling from one star system to another within a reasonable amount of time seems insurmountable. Our current space travel technologies are designed for travel within our own solar system, but even the fastest spacecraft we've built would take thousands of years to reach even the nearest stars. To bridge the vast distances between us and another civilization would require technologies far beyond anything we currently possess. If alien civilizations exist and are capable of interstellar travel, they would need technologies that could bypass the speed of light limitations, perhaps using theoretical concepts like wormholes, faster-than-light propulsion, or other methods we've yet to discover. The idea of faster-than-light travel has long been a staple in science fiction, but some physicists argue that it could be theoretically possible based on our current understanding of general relativity. Wormholes, for example, are hypothetical tunnels through space-time that could potentially create shortcuts between distant points in the universe. While no physical evidence of wormholes has been found, they remain a topic of interest for researchers exploring the possibilities of faster-than-light travel. If alien civilizations are using wormholes or similar technologies, it could explain how they might travel across the galaxy without the limitations of conventional space travel. But this raises another question. If alien civilizations have the ability to travel across the galaxy, why haven't we detected them? Could they be using these advanced technologies to hide their presence from us? One theory proposes that alien civilizations may not be broadcasting signals or traveling to other star systems because they have developed technologies that allow them to remain undetected. If they have found ways to manipulate space-time, cloak their movements, or hide their activities, they may be observing us without us ever realizing it. Even if these civilizations aren't intentionally hiding from us, the vast distances involved may still make it nearly impossible for us to encounter them. The likelihood of two civilizations from different parts of the galaxy being at the same point in time and space and then having the opportunity to make contact is extremely low. The universe is incredibly old, and the chances of an alien civilization existing at the same time as ours and being able to communicate or meet with us are slim. Even if they are out there, we might be separated by millions of years of evolution, technological development, or even sheer distance. The odds of finding a civilization just in the right place and time to make contact seem increasingly improbable. Then there's the issue of the signal detection problem. Even if alien civilizations are sending signals our way, how would we even know what to look for? Our search for extraterrestrial life has largely been based on the assumption that they would communicate in ways similar to us, using electromagnetic waves such as radio signals. But if aliens use completely different forms of communication, perhaps based on quantum processes or other principles we don't yet understand, we might be completely missing the signals they're sending. It's possible that alien civilizations are transmitting messages using technologies that are beyond our current scientific knowledge, and we simply haven't developed the tools to detect them yet. Even the most sensitive instruments we have today, like the SETI radio telescopes, are limited by the bandwidth of the signals that they can detect. If alien civilizations are using higher frequencies or other forms of radiation outside the range of our current technology, our instruments won't be able to pick up their signals. In this case, the silence we perceive could simply be a result of our technological limitations. We might be missing the signals because we're not looking for the right things, or because our equipment isn't capable of detecting them. And what if alien civilizations aren't trying to contact us at all? One possibility is that, like us, they may be focused on exploring their own solar systems or their own galaxies, rather than reaching out to others. They might be content with their own discoveries, and their efforts might be centered around things like interstellar travel within their own solar systems, studying their planets, or expanding their civilizations on worlds closer to them. It's possible that, like us, they haven't even thought about reaching out to other civilizations yet, or they might be waiting for a more opportune time to do so. There's also the possibility that we're simply too early in the timeline of intelligent life. As civilizations tend to self-destruct or fade away quickly in the grand scheme of galactic time, we may just be one of the first intelligent species to emerge. Other civilizations may have already come and gone, or we may be living in a moment when no one else is around to make contact. The timeline of intelligent life in the galaxy could be staggered, with different civilizations emerging at different points in time, separated by millions or even billions of years. If this is the case, we might never find another civilization because we're just at the beginning of our own evolutionary journey. The vast distances and the technological limitations of both our species and any potential extraterrestrial civilizations provide a framework that could help explain why we haven't encountered alien life yet. The universe is incredibly old, incredibly vast, and incredibly complex, and the possibility of two civilizations finding each other at the right time in the right place is rare, perhaps even extremely rare. The Fermi Paradox, when examined through the lens of these challenges, suggests that the silence we experience may be inevitable. Whether through technological barriers, time delays, or vast distances, the odds of making contact with extraterrestrial civilizations seem slim, but not impossible.
As we continue to explore the Fermi Paradox, another intriguing possibility emerges. The idea that alien civilizations might be out there, but they may be fundamentally different from us in ways that we simply cannot comprehend. When we imagine extraterrestrial life, we often think of civilizations that are biologically similar to ours, life forms with similar needs, behaviors, and ways of communicating. But what if the life forms we're searching for aren't bound by the same biological processes that govern us?
This idea pushes the boundaries of what we consider life and opens up the question, what defines life? If alien life exists, could it be so radically different from anything we understand that we might not even recognize it as life? This concept challenges our very assumptions about biology, intelligence, and communication. For example, life on Earth is carbon-based, relying on liquid water, oxygen, and other elements that are familiar to us. But what if alien life doesn't follow these same rules? What if extraterrestrial life is based on a completely different set of chemical processes, perhaps silicon-based, or even something we can't yet imagine? On Earth, we have evolved to thrive in specific environments, but alien life forms might flourish in conditions that we wouldn't consider habitable. Imagine organisms living in extreme environments, sulfuric acid oceans, liquid methane lakes, or even in places where life as we know it couldn't survive. If alien life exists in such environments, we might never detect it, even though it's right in front of us. This leads to the concept of non-carbon-based life. While carbon-based life forms on Earth have evolved into a vast array of species, from bacteria to humans, the possibility of other elements forming the backbone of life, like silicon, raises intriguing questions. Silicon is chemically similar to carbon and can form complex molecules, meaning that silicon-based life could theoretically exist in places that are too hot or too cold for carbon-based life forms. If such life forms exist, they might have evolved to thrive in environments that we wouldn't consider habitable. Additionally, the way alien life might communicate could be completely different from our own understanding. On Earth, we rely on electromagnetic signals like light and radio waves, along with sound waves and chemicals to communicate. But what if extraterrestrial civilizations are using forms of communication based on quantum mechanics, gravitational waves, or even other dimensions of space-time? Their methods of interacting with their environment and with each other could be so beyond our comprehension that we fail to even recognize the signals they might be sending. Alien civilizations might not be sending out radio signals at all. They could be using a technology or medium that is outside the spectrum of our detection tools. If these civilizations exist, they might be so far advanced that their methods of communicating or traveling through space don't even resemble what we think of as technology. Just as the leap from early human technology to the advent of the internet or space travel has dramatically altered our capabilities, an advanced extraterrestrial civilization might have evolved in ways that make their existence difficult for us to detect or understand. There's also the possibility that alien life may not follow the same biological imperatives that we associate with life. Life on Earth is driven by the need for energy, growth, reproduction, and survival. But what if alien life has evolved in such a way that these biological drives are irrelevant to them? They could operate based on different sets of values or desires that don't correspond to our understanding of survival or intelligence. This means that their motivations, behaviors, and even their concept of existence might be so alien to us that we would not even recognize them as intelligent or conscious beings. Furthermore, what if life forms in space don't experience time the same way we do? On Earth, life is governed by the ticking of clocks, by day and night, by the passage of seasons and years. But in the vastness of space, especially near phenomena like black holes or other extreme environments, time itself can behave differently. If alien civilizations evolved in environments where time doesn't flow as we experience it, their entire perception of reality might be fundamentally different. they might not even recognize time as a constant, and their evolution could have unfolded in ways that are completely outside of our comprehension. We also have to consider the possibility that alien civilizations might not be biological at all. They could be artificial life forms, existing purely as highly advanced artificial intelligence or machine consciousness. Such entities might have developed far beyond biological life, and their goals and communication methods could be entirely digital or mechanical. The idea of machine life forms raises questions about consciousness. Could machines develop self-awareness? And if they do, how would they interact with biological life like us? If alien civilizations are made up of machines or artificial intelligence, they might be unrecognizable to us as life, but that doesn't mean they wouldn't be incredibly advanced and capable of exploring the universe. In any case, the idea that alien life might be so fundamentally different from us that we cannot even recognize it suggests that our search for extraterrestrial intelligence may be severely limited by our own assumptions about what life is and how it should behave. The Fermi Paradox may not necessarily mean that extraterrestrial life doesn't exist. Rather, it might indicate that alien civilizations are so far removed from our understanding that we are simply incapable of detecting them with our current methods or technology. This concept forces us to reconsider what we know about the universe and challenges us to expand our understanding of what constitutes life and intelligence. Alien civilizations might be closer than we think, but they could be hiding in plain sight, their existence beyond the boundaries of our perception. As our scientific knowledge grows and our technology improves, we may one day discover that the universe is teeming with life that is so different from our own that we could never have imagined it.
As we explore the Fermi Paradox further, it becomes increasingly clear that the challenges of detecting extraterrestrial life are not just technological, but philosophical as well. The more we examine the possibilities, the more we realize that the absence of evidence doesn't necessarily mean that extraterrestrial civilizations don't exist. It simply might mean that we haven't yet discovered the right approach to finding them. One of the most profound implications of the Fermi Paradox is the way it forces us to confront our place in the universe and how we define life, intelligence, and civilization. Throughout history, humans have assumed that the universe revolves around us. Our entire understanding of life has been based on our own biological and technological experiences. We've developed a framework for what life should look like, what intelligence should be, and how civilizations should behave. But what if the universe doesn't work according to our assumptions? What if the nature of intelligent life is radically different from anything we could ever conceive? The Fermi Paradox highlights the limitations of our perspective. While we continue to search the stars for signs of alien life, we are often constrained by our own definitions of what life and intelligence should be. We've developed a search based on the assumption that alien life will resemble our own form of biological life. We look for planets with conditions similar to Earth's. We listen for radio signals, and we attempt to make contact using methods we understand. But this search is based on the idea that alien civilizations will be similar to us in key ways. What if they aren't?
This challenge is what makes the Fermi Paradox so intriguing and in many ways humbling. It forces us to confront the fact that the universe is vast and our understanding of it is incomplete. We've spent much of our history believing that humanity is the pinnacle of intelligence in the cosmos, but the reality might be far more complex. Perhaps extraterrestrial civilizations have already found ways to exist in forms we can't imagine, using technologies, biological processes, or ways of thinking that are beyond our comprehension. One of the most compelling aspects of the Fermi Paradox is the way it pushes us to reconsider our assumptions about the universe. We've been taught to believe that life is something that must be carbon-based, that intelligence is something that involves reasoning and complex problem-solving, and that a civilization is something that uses tools and communicates through language. But what if these assumptions are too narrow? What if the universe is home to forms of life that are beyond our definition, operating in ways that are completely outside of our frame of reference? This line of thinking challenges us to broaden our concept of what constitutes intelligence and civilization. What if the true nature of intelligence isn't based on how well a species can manipulate its environment or build technology, but rather how well it can adapt to the forces of the universe? What if advanced civilizations are invisible to us because they've learned to exist in harmony with the natural world in ways we can't understand? Or perhaps they've transcended the need for physical bodies altogether, existing in ways that are purely digital or energetic. This philosophical perspective opens up exciting possibilities. If extraterrestrial life exists in forms we can't recognize, it could fundamentally change how we approach the search for life beyond Earth. The Fermi Paradox forces us to acknowledge that our current methods of looking for extraterrestrial life may be inherently flawed, limited by our own expectations. We may be searching for signals in the wrong places, using the wrong tools, or even asking the wrong questions. Another philosophical implication of the Fermi Paradox is its potential to reshape our understanding of humanity's role in the universe. If we are indeed alone in the galaxy, it places a tremendous responsibility on us. We would be the only intelligent life in the entire observable universe, and that could be an amazing and a terrifying realization. It would mean that humanity carries the weight of cosmic responsibility, tasked with protecting and preserving life on Earth, the only known cradle of civilization in the vast universe. The absence of alien civilizations might be a reminder that we are the stewards of our world, and that the choices we make now could have lasting consequences for the future of life. But what if we're not alone? What if there are other civilizations out there, and we simply haven't found them yet? The implications of making contact with an extraterrestrial civilization would be profound. It would challenge everything we know about our place in the cosmos. It would force us to rethink our assumptions about the nature of life, consciousness, and technology. It would likely lead to a revolution in human culture, as we would have to adjust our beliefs, values, and understanding of the universe. In either case, whether we are alone or part of a vast cosmic network of intelligent civilizations, the Fermi Paradox changes the way we view ourselves. It forces us to confront the mysteries of life in the universe and recognize how little we truly know. As we continue to explore space, we must remain open to the possibility that the universe may contain forms of life, intelligence, and civilization that are beyond our wildest imagination. The Fermi Paradox also raises important questions about the future of humanity. If we are indeed alone in the universe, it emphasizes the fragility of life on Earth. It suggests that intelligent civilizations may be rare, and that we must do everything we can to preserve our own civilization before we become another extinct species in the long history of the universe. Alternatively, if we are not alone, the Fermi Paradox reminds us that our search for meaning in the cosmos is far from over. We might be on the cusp of discovering alien life, and the future of space exploration could hold the key to unlocking the deepest mysteries of existence. As we continue to push the boundaries of our scientific knowledge and technological capabilities, the Fermi Paradox serves as a reminder that the universe is far more complex and mysterious than we could ever have imagined. Whether we are on the brink of finding alien life, or whether we are truly alone in the universe, the journey to answer the Fermi Paradox is a journey that will define our understanding of life itself.
As we look toward the future, the Fermi Paradox pushes us to expand our thinking about how we might one day resolve it. Despite all the obstacles we've encountered in our search for extraterrestrial life, there are still countless opportunities for discovery. The universe is vast, and technology is advancing at an unprecedented rate. As we develop new tools and techniques, the possibility of finding extraterrestrial civilizations, whether through direct contact or indirect evidence, remains one of the greatest scientific quests of our time. One of the most exciting avenues for resolving the Fermi Paradox lies in the study of exoplanets. The discovery of planets orbiting stars outside our solar system has opened up a new chapter in the search for alien life. In the past 2 decades, astronomers have discovered thousands of exoplanets, some of which are located in the habitable zone, the region around a star where liquid water could exist. This has led to the possibility that there may be planets out there with conditions similar to Earth's, offering the right environment for life to develop. The ongoing Kepler mission and TESS, Transiting Exoplanet Survey Satellite, are just 2 examples of how space telescopes are expanding our knowledge of the exoplanetary landscape. The James Webb Space Telescope, set to launch in the near future, will allow us to study the atmospheres of these exoplanets in unprecedented detail. By analyzing the light passing through an exoplanet's atmosphere, scientists hope to detect biosignatures, signs of life, such as oxygen, methane, or other chemicals that could indicate the presence of living organisms. This could be a huge step forward in answering the Fermi Paradox. If we detect biosignatures on an exoplanet, it would suggest that life may not only be widespread in the universe, but that intelligent life could also be out there, waiting for us to discover it. Even if we don't find biosignatures immediately, the discovery of more exoplanets is invaluable. Each new discovery adds to our understanding of what makes a planet habitable. We may find planets that are more or less likely to host life, or we may learn about other forms of life that thrive in ways we don't expect. This knowledge will help us refine our search, targeting specific planets where life might exist.
However, finding signs of life isn't the only way to resolve the Fermi paradox. Another approach is to search for alien megastructures, large-scale constructions that could indicate the presence of an advanced civilization. The search for alien megastructures gained attention in 2015 when astronomers observed strange fluctuations in the light emitted by a star known as KIC 8462852, or Tabby star. Some scientists hypothesized that the light variations could be caused by an artificial megastructure, such as a Dyson sphere, a hypothetical structure that could be built around a star to capture its energy. While the megastructure hypothesis has since been ruled out, the idea that we could one day detect such structures has inspired further searches for unusual phenomena in space. In addition to searching for megastructures, there's the possibility of detecting alien signals. While the search for extraterrestrial radio signals through programs like SETI has not yet yielded success, there are still unexplored avenues. Breakthrough Listen, a more recent initiative, aims to scan the entire sky for signs of alien communication. Advances in technology, such as more powerful radio telescopes and more sensitive equipment, make it increasingly likely that we will one day hear something. Even if extraterrestrial civilizations are using communication methods far beyond radio waves, the ability to detect non-traditional signals could provide new insights. There is also growing interest in the study of gravitational waves, ripples in space-time caused by massive objects like black holes and neutron stars. The detection of gravitational waves in 2015 opened up a new way of observing the universe, and some researchers speculate that future discoveries of gravitational waves could help us detect alien activity. If extraterrestrial civilizations are manipulating gravitational fields for travel or communication, we might be able to detect their presence through this method. Gravitational wave astronomy could, in the future, become an important tool in the search for extraterrestrial intelligence. While these advances in technology are exciting, we must also remember that the resolution of the Fermi paradox might not come from a single discovery. It could be a gradual process with multiple discoveries and technological breakthroughs that collectively point to the existence of extraterrestrial civilizations. Whether through the study of exoplanets, the detection of alien signals, or the observation of alien megastructures, each new piece of evidence brings us closer to answering the question, where is everybody? Yet, even as we develop new technologies and search for new forms of evidence, we must also consider the philosophical and existential implications of finding extraterrestrial life. The discovery of intelligent alien life would be one of the most profound moments in human history, but it would also raise a host of complex questions. How would we communicate with these civilizations? What would it mean for humanity's understanding of its place in the universe? Would we reach out to these civilizations, or would we be overwhelmed by the possibility of contact? Would discovering alien life change how we view ourselves, our culture, and our society? These are questions that humanity will need to confront if we ever make contact with extraterrestrial civilizations. At the same time, the absence of evidence also has profound implications. If we are truly alone in the universe, it would be a sobering realization, but it would also place greater responsibility on us as caretakers of the only known planet capable of sustaining intelligent life. The Fermi Paradox, in its mysterious silence, could push humanity to reflect on the importance of preserving life on Earth and ensuring that our civilization continues to thrive. The Fermi Paradox invites us to explore both the cosmic and the philosophical implications of life beyond Earth. It reminds us that in the vastness of space, we may not have all the answers, but our curiosity drives us forward. Whether we are alone in the universe or just waiting to discover someone else, the search for answers continues to shape our understanding of the cosmos and our place within it. As we look toward the future, the possibility of discovering extraterrestrial life remains one of the greatest mysteries of all, one that will continue to challenge and inspire us for generations to come.
As we reflect on the profound mysteries presented by the Fermi Paradox, we must also consider the broader implications of our search for extraterrestrial life, both for science and for humanity.
The paradox doesn't just challenge our scientific understanding, it pushes us to reconsider our philosophy, our place in the universe, and our role in the cosmos. The search for alien life is not only about the discovery of new worlds and new civilizations, it's about understanding ourselves in the vast expanse of the universe. If we are to resolve the Fermi paradox, it's crucial to recognize that the absence of contact with extraterrestrial civilizations may not be a reflection of their absence. It may simply be a matter of miscommunication or misunderstanding. Our current methods of searching for alien life are based on the assumption that extraterrestrial civilizations will follow the same principles of communication and technology as we do. But as we've seen, the possibilities are vast, and alien life may be so different from what we can imagine that we might be looking in the wrong places or using the wrong tools. As we explore the great unknown, the discovery of extraterrestrial life, if it ever happens, will have far-reaching consequences. The implications for human knowledge, culture, and even religion are monumental. What would it mean for humanity if we were to encounter intelligent life from another planet? How would this discovery alter our understanding of our origins, purpose, and future? Many philosophers and thinkers have pondered the impact of discovering intelligent alien life. For some, it might be a humbling realization that we are not the most intelligent or important species in the universe. Others argue that it could serve as a unifying force, a discovery that would unite humanity in the face of a shared cosmic reality. Instead of focusing on our divisions and conflicts, the discovery of extraterrestrial life could force us to recognize our shared humanity, our common planet, and the fragility of life itself. On the other hand, the discovery of alien civilizations might also pose significant challenges to human society. If we encountered a more advanced civilization, would we be able to communicate with them? What would we learn from them? Could we share knowledge and technology, or would we be overwhelmed by their advancements? Would we be prepared for the cultural, psychological, and ethical challenges that come with such a discovery? The prospect of encountering a more advanced civilization raises questions about power, control, and the possibility of exploitation. It could lead to an entirely new set of moral dilemmas for humanity to navigate. Even if we never make contact with extraterrestrial life, the very act of searching, of reaching out into the vastness of space, has its own significance. The human drive for exploration is deeply embedded in our nature. We have always sought to explore the unknown, from the first human migrations across the Earth to the first journeys into space. This drive to explore is not just about discovering new places, it's about discovering new ideas, new possibilities, and new ways of thinking. The quest to understand our place in the universe is a reflection of our desire to expand our knowledge and understanding. The search for extraterrestrial life, in many ways, reflects the very essence of what it means to be human. It's a search for meaning in a vast and often indifferent universe. It forces us to ask fundamental questions about the nature of life, the limits of our knowledge, and the future of our species. The Fermi Paradox, by presenting us with the mystery of alien life, challenges us to reconsider our assumptions and confront the uncertainties of our existence. It invites us to think bigger, to see the universe not as a place where humanity is the center, but as a vast and complex system filled with infinite possibilities. As we continue to search for answers, we must remain open to the idea that the universe may not conform to our expectations. Alien life may not look or behave in ways we imagine. We may never encounter aliens in the way we hope, or perhaps we are simply too early in the timeline of intelligent civilizations. The Fermi Paradox reminds us that, even with all of our advancements, we are still very much at the beginning of our journey to understand the universe. Our search for extraterrestrial life is just one part of a much larger cosmic puzzle. And while the Fermi Paradox may remain unsolved for now, it does not diminish the importance of the search itself. The pursuit of knowledge, the quest to understand our place in the universe, is an endeavor that shapes our future. The questions we ask and the discoveries we make along the way are just as important as the answers we hope to find. The Fermi Paradox, with all its mystery and uncertainty, is a reminder that the universe is vast, and the search for life beyond Earth is one of the most profound quests humanity can undertake. Whether or not we ever find extraterrestrial life, the search itself enriches our understanding of who we are. It challenges us to think beyond the limitations of our world and our current understanding of life. It encourages us to continue asking questions and to push the boundaries of our knowledge. In the end, the Fermi Paradox may not only reveal the answers we seek about alien life, it may also illuminate the deeper truths about ourselves and our place in the cosmos.
As we continue to unravel the Fermi Paradox, we must also consider the long-term implications of the search for extraterrestrial life, both for humanity and for the future of space exploration. While the absence of evidence for alien civilizations may seem disheartening, it also points us in a new direction: the potential for self-discovery and self-preservation. If we truly are alone in the universe, the responsibility to protect and sustain life on Earth falls squarely on our shoulders. The Fermi Paradox is a reminder that our planet is precious, unique, and fragile, and it may be the only home we have. If humanity is to thrive in the long term, we must continue to explore space, advance our understanding of the universe, and seek out new frontiers. The question of whether we are truly alone or not may one day be answered, but for now we have to focus on ensuring the survival and prosperity of our own civilization. Our search for extraterrestrial life is not just about finding others, it's about learning to care for ourselves and our planet. The very nature of the Fermi Paradox encourages us to think on a cosmic scale. It forces us to confront the idea that, in the grand timeline of the universe, our civilization is just a fleeting moment in time. Human history spans only a few thousand years, a blip compared to the 13.8 billion years of cosmic history. Yet, in that brief period, we've accomplished remarkable feats. We've landed on the moon, sent probes to the outer reaches of the solar system, and are now on the cusp of sending humans to Mars. We are taking our first steps into the vast cosmos, and this journey will continue to unfold in the centuries and millennia to come. As we venture further into space, we may one day encounter new challenges that will require us to adapt and evolve as a species. The discovery of alien life, or the realization that we are completely alone, will shape the future of our society and influence the direction of scientific research and technological innovation. Whether or not we find life beyond Earth, our pursuit of answers will drive human progress. One of the most important aspects of this journey is our ability to work together as a species. The search for extraterrestrial life is a global endeavor, one that transcends national borders and political divisions. It calls on the best minds from all over the world to collaborate, share knowledge, and push the boundaries of what we know. The Fermi Paradox, in many ways, underscores the need for global cooperation in addressing the great challenges that lie ahead. Whether we are exploring the farthest reaches of space or solving problems on Earth,
The future of humanity depends on our ability to unite for the common good. At the same time, we must recognize that our journey into space is not just about technological progress, it's about philosophical growth as well. The Fermi Paradox challenges us to think more deeply about our place in the universe. If we are truly alone, we must ask ourselves, what does that mean for our purpose as a species? What is our role in the cosmic drama? And how should we conduct ourselves in a universe that may be teeming with potential life, or perhaps is entirely devoid of it? If we eventually make contact with an alien civilization, it will challenge everything we know about our identity and humanity. We will be forced to confront our assumptions about consciousness, culture, and intelligence. Such a discovery would forever change the trajectory of human civilization, just as it would raise profound ethical and moral questions. How would we relate to beings who are so fundamentally different from us? What would we learn from them, and what could we share in return? Would the discovery of alien life lead to a new age of cooperation and exploration? Or would it bring about conflict and division? On the other hand, if we never find extraterrestrial life, it's possible that humanity will turn inward, focusing more on preserving our planet and ensuring the long-term survival of our species. Without the distractions of interstellar exploration or contact with alien civilizations, we may be forced to reckon with the existential questions that the Fermi Paradox raises. What does it mean to be the only intelligent species in the galaxy? And how can we ensure that our legacy, as the sole stewards of this planet, is a positive one? The Fermi Paradox challenges us to recognize that life, whether we find it or not, is fragile. The search for alien life is not just about finding answers, it's about understanding the preciousness of life itself. We live on a single planet in a vast and expanding universe, and the Fermi Paradox reminds us that we have a responsibility to safeguard our world. If Earth is the only home for life as we know it, it is up to us to protect it and make sure that life continues to thrive. Ultimately, the search for extraterrestrial life serves as a reflection of our own human curiosity, resilience, and spirit of discovery. Whether we encounter alien civilizations or not, the journey to explore the cosmos will continue to shape our understanding of who we are and what our place is in the universe. The Fermi Paradox, in all its mystery, invites us to look up at the stars and ask the fundamental questions about life, intelligence, and existence. It's a reminder that no matter how vast the universe is, the search for meaning is always at the heart of human exploration. As we continue our exploration of space, one thing is certain: the Fermi Paradox will remain a central part of our quest for knowledge. It will push us to expand the boundaries of science and philosophy, and it will challenge us to confront the deepest mysteries of the universe. Whether we find alien life or not, the search will continue to drive humanity toward greater understanding, cooperation, and ultimately a deeper connection with the cosmos itself.
As we delve further into the potential resolutions to the Fermi Paradox, we must also consider the future of humanity in the context of the cosmic scale. The search for extraterrestrial life is not just about answering one of the greatest scientific mysteries. It's about shaping the trajectory of our species as we look toward the stars. Whether or not we ever find definitive proof of alien life, the journey itself will continue to influence our technological, philosophical,
and cultural development. One of the most pressing questions that the Fermi Paradox raises is whether humanity is ready for the potential discovery of alien civilizations. If we do find signs of intelligent life, how will we respond? Would the revelation of extraterrestrial life fundamentally change our understanding of human significance? And, perhaps even more profoundly, could it lead to a new era of human collaboration? The possibility of encountering alien civilizations, especially more advanced ones, opens up a myriad of potential scenarios. If we were to detect a signal from another world or make direct contact with an extraterrestrial civilization, we would be forced to reconsider human superiority and dominance in the universe. For centuries, humanity has viewed itself as the pinnacle of intelligence, the ultimate expression of life and consciousness in the universe. The discovery of intelligent alien life would challenge this view and force us to reframe our understanding of our place in the cosmos. It could be humbling, inspiring, or even disorienting. Such a discovery could also lead to new opportunities for scientific collaboration. If aliens are more technologically advanced than us, they could offer valuable knowledge about space travel, energy production, or even the nature of the universe. The possibility of exchanging information and technology could lead to an explosion of innovation, much like how the Renaissance was a period of rapid scientific and cultural development. On the other hand, there's also the risk that the contact could be hostile, or that the gap between our civilizations could prove insurmountable. The discovery of alien life would certainly raise complex ethical questions about power dynamics, exploitation, and the potential for cultural or technological exchange. On the other hand, if we never find alien civilizations, it's still essential to reflect on the implications of being alone in the universe. The realization that Earth is the only planet with intelligent life could lead to a profound sense of responsibility. If we are the only species capable of self-awareness, space exploration, and technological advancement, the burden of preserving life on Earth would fall solely on us. We would be the caretakers of the only known living planet in an empty universe, and the importance of sustainability, global cooperation, and environmental preservation would become even more urgent. The question of being alone in the universe also brings us face to face with existential challenges. If we are the only intelligent life in the cosmos, it may push us to consider our purpose in a universe that has existed for billions of years without us. What does it mean for humanity to be the sole conscious observer in an otherwise indifferent cosmos? This might force us to rethink not just life's meaning, but also our goals and priorities as a civilization. The Fermi Paradox in this context serves as a kind of cosmic mirror, reflecting back to us the complexities of our own existence and the uncertainty of our future. If we find that we are alone, it could lead to a renewed focus on solving the problems that threaten our survival, such as climate change, nuclear proliferation, and the potential collapse of ecosystems. The absence of any other intelligent civilizations could become a clarion call for humanity to act with greater urgency. We would be forced to recognize that our future is not only in our hands, but also in the hands of every generation that comes after us. With no one else to rely on, it would become our responsibility to make the Earth a sustainable and thriving home for future generations. Another aspect of the Fermi Paradox is the concept of cosmic isolation. If Earth truly is the only planet with intelligent life, it raises the question of whether intelligent life is a rare phenomenon or whether it simply hasn't had the right conditions to emerge elsewhere. The vast empty spaces between stars and galaxies could be evidence of how difficult it is for life to thrive in the universe. Or perhaps life itself is more resilient than we think. It may have emerged in many places, but just as we struggle to communicate across vast distances, other civilizations may be facing similar barriers to contact. The universe could be full of intelligent life, but it may just be separated by the vast distances of time and space. At the same time, we have to consider the possibility that intelligent life may exist in forms we cannot even comprehend. We may be searching for life that fits our biological template, while intelligent life may have evolved in ways completely different from our own. Perhaps extraterrestrial civilizations are living in forms that don't resemble anything we recognize as life at all, such as machines, artificial intelligences, or beings that exist purely in energy forms. As we continue our exploration of the cosmos, we may come to realize that our search for life has been limited by our own definition of what life should be. As the search for extraterrestrial life continues, one thing is certain: the journey itself is shaping the future of humanity. Whether or not we ever make contact with an alien civilization, the effort to understand the universe, to expand our reach into the cosmos, and to answer the Fermi Paradox is a crucial part of what makes us human. The questions we ask and the discoveries we make, whether we find life or not, will continue to inspire future generations of scientists, thinkers, and dreamers. And no matter the outcome of our search, the quest to explore the universe will never cease. The Fermi Paradox will continue to provoke thought, challenge our assumptions, and ignite our curiosity about what lies beyond our planet. It will remind us that the universe is vast and that there are still so many mysteries to uncover. Whether or not we find answers, the very act of asking questions and searching for truth will drive humanity forward into an exciting, uncertain future.
As we continue to explore the ramifications of the Fermi Paradox, it's essential to consider how this paradox shapes not just our future, but our current approach to space exploration. While the absence of alien life might initially seem like a scientific dead end, it is equally possible that it is merely an indication of our current limitations. The search for extraterrestrial intelligence, SETI, has been ongoing for decades, and though it has yet to yield conclusive evidence of alien life, the search itself has provided numerous technological and intellectual advancements that benefit humanity as a whole. One of the most promising developments in the search for alien life is the continued exploration of exoplanets. As we discover more and more planets orbiting stars in the habitable zone, the potential for finding life elsewhere increases. While we may not yet have detected life on these planets, our study of exoplanets has already revealed much about the conditions that might support life. Through missions like the Kepler Space Telescope and TESS, we've learned that Earth-like planets may be much more common than once thought. This discovery, in itself, has expanded our understanding of the universe, showing us that the conditions necessary for life may not be as rare as we previously believed. As technology continues to advance, the way we search for extraterrestrial life will also evolve. For example, the James Webb Space Telescope, scheduled for launch in the near future, will provide unprecedented views of distant exoplanets. By studying the atmospheres of these planets in infrared wavelengths, scientists hope to detect biosignatures, chemical markers that could indicate the presence of life. This will be a huge leap forward in the search for life beyond Earth, and it could be the key to answering the Fermi Paradox. If we find evidence of biosignatures on another planet, it would suggest that life, or at least the potential for life, is widespread across the universe. This discovery would change everything, shifting our understanding of the cosmos and our place in it.
The advancements in technology that are helping us explore the cosmos, however, are not limited to space telescopes. The field of artificial intelligence, AI, has the potential to revolutionize how we search for alien life. By using machine learning and AI algorithms, scientists can process and analyze vast amounts of data from telescopes and space missions more quickly and accurately than ever before. This allows us to detect patterns and signals that may have been overlooked by human researchers, increasing our chances of finding signs of extraterrestrial life. AI could play a pivotal role in interpreting alien signals, if they exist, and could one day help us make contact with other civilizations. Beyond the tools we use to search for life, there is also the matter of our own human exploration of space. The long-term goal of humanity should be to become a multi-planetary species. This means not only exploring other planets in our own solar system, but also colonizing other worlds. The recent success of private companies like SpaceX in advancing rocket technology has brought us closer than ever to becoming an interplanetary species. With the potential to send humans to Mars, the idea of life on other planets is no longer a distant dream. Establishing a permanent human presence on Mars would not only pave the way for future interstellar exploration, but it would also make us more resilient as a species. It would provide a backup for humanity in case of catastrophe here on Earth. While the Fermi Paradox challenges us to consider the possibility of alien civilizations, it also underscores the importance of our own survival. If we are indeed the only intelligent species in the universe, we bear an enormous responsibility for the future of life. The absence of extraterrestrial life could serve as a call to action, urging us to protect the planet that supports us. Climate change, environmental degradation, and the potential for nuclear conflict present real threats to the future of humanity. The Fermi Paradox reminds us that we are the custodians of Earth, and if we do not take care of our home, there may not be other civilizations out there to help us. At the same time, the search for extraterrestrial life keeps us focused on the unknown. It challenges us to think bigger than our immediate concerns and forces us to contemplate the cosmic perspective, that we are part of something far greater than our planet, our species, or even our galaxy. Whether or not we ever make contact with alien civilizations, the journey of exploration and discovery is inherently human. It is about curiosity, about pushing the boundaries of knowledge, and about expanding our understanding of the universe. The Fermi Paradox is, in many ways, a reflection of the human condition. It raises profound questions about our place in the universe and the nature of life itself. But it also drives us forward, challenging us to think beyond our immediate reality and consider the long-term future of humanity. The paradox forces us to reckon with the limits of our knowledge, while at the same time inspiring us to continue our quest for answers. Whether we're alone or not, the search for extraterrestrial life will continue to shape our scientific endeavors, our cultural perspectives, and our vision of what is possible. In the end, the Fermi Paradox serves as a reminder that the universe is vast, mysterious, and full of possibility. The question of whether we're alone is one of the greatest challenges of our time, but it is also one of the most exciting. As long as we continue to ask the big questions, to search the stars, and to dream of what lies beyond, we are participating in something much larger than ourselves. The Fermi Paradox is a cosmic invitation to explore the unknown, to embrace the wonder of discovery, and to seek the answers that will guide humanity's future.
As we move closer to unraveling the mysteries behind the Fermi Paradox,
We must also look at how our search for alien life intersects with broader scientific endeavors and the potential long-term survival of humanity. Whether we eventually find evidence of extraterrestrial civilizations or not, our quest to understand life beyond Earth is intrinsically tied to our own understanding of life, consciousness, and intelligence. The search for alien life isn't just about finding answers. It's about pushing the boundaries of human knowledge and exploring the limits of what we can discover. But as we venture further into space and uncover new frontiers, we must also be mindful of the risks and challenges that come with technological advancement and interstellar exploration. One of the most exciting aspects of the search for extraterrestrial life is the exploration of new worlds. As we continue to discover exoplanets in the habitable zones of distant stars, the potential for discovering new environments that could support life continues to grow. These exoplanets provide valuable insights into the conditions that allow life to flourish. By studying their atmospheres, surface conditions, and potential biosignatures, we can learn more about the fundamental principles that make a planet habitable. This knowledge may eventually lead us to a deeper understanding of the forces that govern the emergence of life across the universe. But exploration is not just about looking for signs of life. It's also about preparing ourselves for the challenges that lie ahead. As we reach for the stars, we must consider the technological and ethical dilemmas that come with venturing beyond our planet. The technologies required for long-duration space travel, colonization of other planets, and the potential establishment of permanent human settlements on Mars and beyond are still in their infancy. We must develop spacecraft capable of traveling vast distances, while also ensuring that our exploration does not interfere with the environments we encounter. There's a delicate balance between exploration and preservation, especially when considering the potential for discovering alien ecosystems that might harbor microbial life. Space exploration also forces us to rethink our ethics and the responsibilities we have as humans. If we do discover microbial life on another planet or within one of our solar system's moons, such as Europa or Enceladus, we would be faced with difficult questions about how to interact with that life. Should we conduct experiments or explore these worlds at all? How do we balance the potential scientific benefits of discovering life with the ethical imperative to protect that life from harm? These questions mirror the debates we face today about environmental conservation and the intrinsic value of life. The search for alien life in many ways reflects our broader moral struggle. How do we coexist with and protect the life forms we encounter, whether here on Earth or on distant worlds? While exploring the possibility of discovering alien life, we must also confront our own place in the cosmic timeline. The Fermi Paradox forces us to ask whether we, as a species, are part of a larger pattern of intelligence that stretches across the galaxy, or if we are truly alone in a vast and uncaring universe. The fact that we have not yet made contact with alien civilizations has prompted many to consider the possibility that we are one of the first, or perhaps even the first, intelligent species to emerge. The discovery of alien life would prove us wrong, but it might also challenge us to think more deeply about the very nature of civilization and progress. If we are indeed among the first to reach a level of technological and intellectual maturity, then the responsibility we carry becomes all the more significant. We might be tasked with guiding the development of future civilizations, or perhaps even playing a role in the formation of galactic cooperation and diplomacy. On the other hand, if alien civilizations have come before us and are simply avoiding us, we must confront the reality that advanced civilizations may self-destruct long before they have the opportunity to make contact with others. This raises uncomfortable questions about our own trajectory as a species. How do we avoid the fate of other civilizations that might have come and gone, leaving behind only faint traces of their existence?
The Fermi Paradox also prompts us to explore the broader question of whether intelligence itself is a sustainable trait. While humans are currently capable of remarkable technological achievements, we are also faced with significant existential risks. The rapid pace of technological advancement has introduced new dangers: climate change, nuclear proliferation, and the potential for artificial intelligence to surpass human capabilities. These are risks that could threaten the very survival of our species. If the Fermi Paradox teaches us anything, it's that intelligent civilizations may not last long enough to make contact with others. Perhaps intelligence itself is a fleeting phenomenon, and advanced civilizations are doomed to destroy themselves before they have the opportunity to establish lasting communication across the stars. In contemplating these risks, we must also think about the future of space exploration and interstellar travel. As we begin to understand the mechanics of interstellar distances and work on technologies that might one day allow us to travel beyond our solar system, we must also consider the potential for human expansion across the galaxy. Space is not just the final frontier, it is the only frontier that could ensure the long-term survival of our species. Establishing colonies on other planets or moons could provide humanity with a backup in case of catastrophic events on Earth. It could offer new opportunities for scientific discovery, resource acquisition, and a new chapter in the human story. But such expansion raises significant ethical, cultural, and philosophical questions. How do we approach the colonization of new worlds without repeating the mistakes of the past, especially with regard to the treatment of indigenous ecosystems and potential alien life? The Fermi Paradox, in its complexity, urges us to reflect on the human spirit of exploration and its consequences. Whether we find alien civilizations or not, the pursuit of knowledge is a fundamental aspect of our nature. We are driven to ask questions, to push the boundaries of our understanding, and to seek answers to the mysteries of the universe. The journey to explore the stars may ultimately shape the destiny of our species. Whether through direct contact with alien life, interplanetary colonization, or the discovery of life forms in the most unexpected places, humanity's search for the unknown will continue to inspire and challenge us. As we venture deeper into space, the Fermi Paradox serves as a reminder that no matter how advanced our technology becomes, there is still much to learn. The universe is vast, and the questions we ask today will lead to discoveries that we can't yet imagine. The search for extraterrestrial life may not offer immediate answers, but it will push us toward new frontiers of knowledge, understanding, and possibility. It's a journey that will continue to shape the future of humanity, one that is fueled by curiosity, driven by wonder, and guided by the hope that we are not alone in the cosmos.
As we continue to grapple with the mysteries of the Fermi Paradox, one of the most profound aspects of this puzzle is how it forces us to confront our own future. Whether or not we find extraterrestrial life, the very search for it is reshaping the course of human civilization. It's a journey that is about much more than just answering one scientific question. It's about exploring the limits of human potential, understanding the fragility of life, and determining the long-term direction of our species. The Fermi Paradox has a way of turning our gaze inward as much as it turns it outward toward the stars. If we truly are alone in the universe, the weight of that realization may drive us to reconsider our role in the cosmos. The absence of other civilizations may serve as a powerful reminder that if we don't protect ourselves and our planet, we may be the last intelligent species in the universe to ever exist. The search for alien life is not just about finding others, it's about ensuring the continuity and sustainability of life on Earth. Whether we are alone or not, the choices we make today will shape the future of life for generations to come.
The question that arises from the Fermi Paradox is whether humanity is prepared for the responsibility of becoming the stewards of the galaxy, if indeed we are the first or the last civilization. The answers we seek through space exploration are intertwined with the need to address the existential risks we face here on Earth. The global challenges we face, climate change, nuclear weapons, and resource depletion, threaten our way of life, and our survival as a species is not guaranteed. If we are to thrive long enough to answer the Fermi Paradox, we must first ensure that we take care of our planet and work together to address these urgent issues. As we venture into space, the implications of interstellar travel and colonization only add more complexity to the Fermi Paradox. If we eventually discover alien life, it could radically change the course of human history. But even if we don't, the future of space exploration will still be a journey of immense importance. The technological advancements that allow us to explore other planets and moons will also have the potential to benefit humanity here on Earth. New technologies for resource extraction, energy production, and sustainability could improve life on our planet and help us address some of the most pressing challenges of our time. In the next few decades, humanity may be able to send humans to Mars and beyond. These ambitious missions are not just about establishing colonies on other planets. They are about developing new ways of living and surviving. The ability to build self-sustaining colonies on other worlds could be the key to ensuring humanity's survival in the long run. It could provide a backup for our species in the event of a catastrophic event on Earth, whether it be a natural disaster or the result of human actions. Colonizing other planets would force us to develop new technologies for life support, food production, and resource management, advancements that could ultimately benefit humanity on Earth as well. However, colonizing new worlds also presents ethical challenges. How do we balance our desire to explore and settle other planets with the need to preserve the environments we encounter? The potential for discovering microbial life on Mars or on the moons of Jupiter and Saturn adds a layer of complexity to our exploration efforts. If we find life, even at a microbial level, would we be justified in altering the environments of those planets for our own benefit? Or should we leave them untouched to preserve the possibility of life's natural development? These are the kinds of ethical dilemmas humanity will face as we expand our reach into the cosmos. The idea of human expansion into space brings us back to the idea of humanity's responsibility, both to the Earth and to the universe. If we are the only intelligent species in the galaxy, it becomes even more important that we preserve life on Earth and protect our planet from the forces that could lead to its destruction. The discovery of alien life would certainly be monumental, but the absence of such life could be just as significant. The Fermi Paradox forces us to ask, what if we are the only ones? And if we are, what does that mean for our future? The notion of humanity as the only intelligent life in the galaxy is a sobering one. It underscores the unique position we find ourselves in, where we are tasked with the preservation of life across the universe. While we continue our search for extraterrestrial life, we must also be mindful of the fact that our actions here on Earth can have far-reaching consequences, not only for our survival, but for the survival of life as we know it. The Fermi Paradox challenges us to take responsibility for our actions and to ensure that we do not squander the incredible opportunity we have to live in this universe. Even if the search for alien life never yields concrete results, the exploration of space will continue to inspire humanity to think beyond the limitations of our planet. The Fermi Paradox is a reminder that there is more to the universe than we can yet understand. As we continue to expand our knowledge, we may eventually uncover new discoveries that change the way we think about life, intelligence, and the universe itself.
The Fermi Paradox doesn't just ask us to look outward at the stars, it asks us to look inward at who we are, what we want to become, and what we are willing to risk in the pursuit of knowledge. The journey to answer the Fermi Paradox is one of deep introspection, as much as it is a scientific quest. It challenges us to rise above our fears, our limits, and our assumptions, and it urges us to push forward into the unknown. At the heart of this paradox is the human desire to explore, to discover, and to understand. Whether we find answers or not, the pursuit of knowledge about the universe is a fundamental part of what it means to be human. The Fermi Paradox will continue to shape our future, guiding us toward new discoveries, new technologies, and new ways of thinking. And in that journey, we will continue to redefine who we are and where we are headed in the cosmos.